back to Entrance and Beyond. And today we are going to look at question number 169, majority elements on LeetCode. So let's jump right in. So the question states, given an array nums of size n, return the majority element. The majority element is the element that appears more than and divide by 2 times. So this basically means we are truncating it down. And you may assume that the majority element always exists in the array. So this makes it clear that there is only a single majority element and we have to simply return that. So let's look at the test case. So the first test case nums is equal to 3 comma 2 comma 3. So if we do n divided by 2, that would basically give us 3 divided by 2, that's actually 1.5, but since we are truncating down anyways, it's going to give us 1. And in C++, anyways, 3 divided by 2 would yield 1, so that doesn't really matter. So we have to return the element whose frequency is greater than 1. So in this case, the frequency of 3 is 2, and the frequency of 2 is 1. So we are simply going to return element 3 because it has a frequency greater than 1, and that, as you can see, is the output. And in the second test case, we have 2 comma 2, then we have 3 ones, 2 comma 2. So this is the array. So if we end up dividing 7 by 2, so as you can see, 3 6 7 7 by 2 would basically yield 3. So we have to return the element which appears more than 3 times. So 2 appears more than 3 times, and that is pretty much it. And an interesting follow-up that they ask is, could you solve the problem in linear time and in big O of 1 space? So let's dive into the solution. So the most intuitive sort of solution would be using a data structure that would store the frequency of each of the elements. Then we traverse through that data structure again. We check whether the frequency of a given element is greater than the threshold, so that is basically n divided by 2. If it is, we can store that in a variable known as answer and simply return that. So as you can see, I've done the dry run over here. So as you can see, we're going to go, it's going to start off at 3, add 3 to the data structure, 3's frequency becomes 1, then 2, since 2 is not present in the data structure, 2's frequency becomes 1, and 3 is present in the data structure as we can see, so 3's frequency basically becomes 2 now. So by now it's probably clear that the data structure that I'm talking about is going to be an unordered map because we are storing key value pairs at the end of the day, like we saw yesterday. So this is pretty much the first approach that we could follow. So let's just write the code for that. So we're going to take an unordered map. And why are we taking an unordered map? Because again, the order of elements doesn't really make a difference. So the key would be an integer that would represent the number, so nums of I, and int would basically represent the frequency of a given number. So that is what we have, and then we're going to take int answer to store the answer. We're going to traverse through num, so I is equal to 0, I is less than nums dot size. Then we're going to do I plus plus, simple as that, and then we are going to do frequency of I, frequency of nums of I, frequency of nums of I plus plus. So we have created our unordered map and we have populated it. Now we just have to go through it once and find out the required answer. So we're going to do auto f in frequency. This is known as a range-based loop, so you can research a bit about that as well. And this is the syntax, so auto f, because we want the compiler to automatically understand what f is, or you could explicitly mention it as well, but we're using auto in this case. So auto f, because now what we're going to do is we're going to check if f dot second, that is basically frequency of a given element, if it is greater than nums dot size divided by 2, we're going to store it in answers, and then we can break since we have found the answer. Answer is equal to f dot first, and simply then we can break out of this. We don't need to iterate after we have found the element to return, and in the end we can just end up returning answer. Let's see if it runs. So as you can see, it did run. The only issue was that we were not able to clear the follow-up because we did solve in linear time complexity, but space-wise we are taking big O of m, where m is the number of unique elements. So this isn't the most optimal solution to this question. So now let's look at the most optimal solution for this given question. Now we're going to study an algorithm known as Boyer-Moore majority voting algorithm. So let's dive into the logic. So for now what I'm going to do, I'm going to copy this big input right over here. So I'm going to copy this and I'm going to work forward with it. Now this is our input. So input num is something like this. Now this is our input. Now if we think mathematically or intuitively, we know that if an element appears more than half the time, so n is the size, right? So n divided by 2 basically means half. So if an element appears more than n divided by 2 times, we know there cannot be another element that appears more than n divided by 2 times, because if that would be the case, for example, suppose 2 appeared, I don't know, 2 appeared how many times? Suppose 2 appeared 4 times, and 1 also appeared 4 times. So in this case, n divided by 2 basically yields us 3. So we're looking at a value that is greater than n divided by 2. So suppose 2 appeared 4 times and 1 appeared 4 times. So the total number of elements in our array would end up being 8. And that is not possible because we can clearly see that our input array was of size 7. So it's quite clear mathematically that if an element appears more than half the time, there cannot be another element that appears more than half the time. So we clearly know that there is going to be one element that appears more than half the time. So that is the mathematical logic behind the algorithm that we will be studying right now. So it's simple. So what we're going to do is we're going to take two variables. One would basically be an element. One would be an element and one would be count. So element is something known as candidate element. So we are assuming that this is the element that appears more than n divided by 2 times. So that is what we're doing, and count would basically store the frequency of that given element. So let's suppose we both set it up as 0. Now what we're going to do is we're going to traverse through our array. So let's shift this array a bit to the side so that we can actually traverse it and understand the solution. So what we're going to do is we're going to start off in this array. So the first element that that appears, that is, if that is the element, we are going to increase element by 1. And if that is not the element, we are going to decrement count by 1. And if count is already 0, like we can see count is 0 in this case, so the element would become this element 2, and then count would become 1. Now we go to the next element, that is another 2. So as you can see, 2 is present in element. So we can say that the count of 2 now becomes 2. Now what do we have? We have 1. Now as you can see, count is greater than 0 and 2 is not equal to 1. So we can say that the count decreases by 1. So it becomes 1 now. Now another one appears. So count would now become 0. Now when this one appears, something special is going to happen. So since the count is basically equal to 0, what we're going to do is we're going to update element and consider 1 to be the element, and its count is now going to be 1. Now we come to 2. Now count would decrement since 1 is not equal to 2, so this becomes 0. And now when another 2 comes, what we can notice is that these elements are not equal and count is equal to 0 at this point of time. So this would become 1, and in the end this would become 2, and 2 would actually be the answer that we are supposed to return. So what exactly are we doing? You might have understood the logic, but you probably didn't understand this candidate key and count sort of thing, right? So what are we doing? So to understand that, let's suppose we sort the array, just for your understanding. So we have something like 1, 1, 1, 2, 2, 2. We are essentially just canceling elements against each other. So like if for this one we're canceling this 2, for this one we're canceling this 2, and then for the last one we are canceling this 2 right over here, and 2 is the element that remains, and that would be our answer. So that is pretty much all that we are supposed to do in this algorithm. If it still doesn't make sense, you can maybe search it up at ChatGPT, so it could give you a better maybe explanation if I am unclear in my explanation at all. But this is the logic. We are essentially canceling out elements, and the element that remains in the end, that would be our element that appears the majority number of times. Because as you can see, we already mentioned that there can be only one element that appears more than n divided by 2 times. So if we cancel out all the other numbers, so suppose number 2 appears 4 times, right? So we can cancel out 4 with the remaining n divided by 2 numbers, so that would be 3 numbers. So 2 would still be the element that remains in the end. So that is basically what we're doing. Since we know that no other element can appear more than n divided by 2 times. So even if we cancel a given element with all the other elements present in the array, we know that if it is the majority element, it still is going to remain intact after doing this entire thing. So that is pretty much what we are going to do to solve this question. And as you can see, we're just using variables, so the space complexity would now be optimized. We're going to take constant space to solve this question. And again, constant time again, because we're just going to use a for loop. Simple as that. So what I'm going to do is, so nums.size can be 1, right? Can be 1. So what I'm going to do is I'm going to consider the first element to be the candidate element. So we're assuming that this element appears more than n divided by 2 times. So it's going to be nums of 0. That is all that we're going to do, and we are going to then do int count, set it up as 0. So we're going to do for int I is equal to 0, I is less than nums.size. We're going to do I plus plus. So first we're going to check if element, okay, if the element is equal to nums of I. In that case, we don't really have to do much. We can just increment count. Now, the other case would be if the element is not equal to nums of I. So we're going to take an else case, and within them there were 2 conditions. So if the count is greater than 0, in that case we're just going to do count minus minus. And the other case, if the count becomes 0, so we can say else if the count is equal to 0, we are going to assume the new element to be our candidate element. So element is equal to nums of I, and then we can do count plus plus, because now the frequency of this given element is 1. So we're done with the else loop, we're done with the if loop. This is for the for loop, and this is the end of our function. So we can now return element, and let's see if this code works out fine or not. As you can see, it works perfectly fine. So this was the best approach. Hopefully you understood this question, because when I was solving it initially, I also didn't really understand this algorithm at all. But hopefully you understood this algorithm, and you can drop down in the comment section the next problem that I should be discussing. So thank you so much for tuning in.